Solve the system. So here's a system of equations, three equations, three unknowns. For every unknown, you need an equation. So if we had four unknowns, you would need four equations to be able to solve. Our objective is to put a zero here, here, and here. If we put a zero in these positions, notice if these were zeros, I would be able to know what the z was. I could solve for z. And then this z can be passed to the second and third row, since the z here would equal the z everywhere else. Once I pass the z here, I could solve for the y. So by the time I'm done with this one, I would know y and z, and I would pass it to the first equation, and then I would solve for the x. So you could add any row to any row, and you could multiply any row by whatever number you like except 0. So I'm going to multiply row 2 by a -1. It has to be the whole row, both sides of the equation. This is a result. Slide row 3 underneath it. Combine like terms, column by column. And this equation is going to replace row 2. So here's the new row 2. Now we're going to find a 0 here. We're going to work to get a 0 here. So I multiply row 3 by a -2, the whole equation. Slide row 1 over it. Now if I add these column by column, this is what I get. Now this equation is going to replace row 3. So this is going to go here. So now that we have that row 3, the one we just said we were going to put there, now we're going to work to get a 0 here. So multiply row 3 by a -2, the whole row. This is the result. Slide row 2 over it, combine like terms, and replace row 3 with this equation. So here's the new row 3. Now back substitute. Back substitute means you start from the bottom and go up. And we start from the bottom because the third equation has only one variable to solve for. So you solve for that variable. Turns out to be z is 1. That means all these z's are 1. So now we're going to pass that z equal 1 to the second row so we could solve y. So we gave it to the second row, z equal 1, substitute it. Start moving things away from the y. We're going to solve for the y. So move that 1 over. Then divide both sides by a -2 to get this -2 to the other side. Finally, you have the y by itself, and y equals -1. So at this point, we know z and we know y. Now give that information to row 1. So row 1 is going to use that information. Replace the y and the z with their values. Combine, collect, then solve for x. So start moving all the numbers away from the x. Finally, we have an x equaling 2. So the solution for this system is 2, -1, 1. You always put the x first, then the y, then the z. If you would have graphed those three equations in the original system, there would have been 3 lines, and they would have intersected at this point. Here's another way you could do things faster. But notice I'm changing the system of equations into an augmented matrix. This is called an augmented matrix. Then we use the Gauss-Jordan elimination approach. The Gauss-Jordan elimination approach requires that we have these 3 zeros here and these 3 zeros. But you can start getting answers if you go halfway. So if you just get these 3 zeros, you can start getting some answers. So you remove all the letters. You just put the coefficients. The coefficients is the number part. Notice all the letters are gone. That's going to save you time since you won't have to be writing the letters over and over. Our objective is the same. We need a 0 here, here, and here. So we multiply row 2 by a -1. Slide row 3 underneath it. Combine like terms. And then this is going to replace row 2. This is the new row 2. So it goes here. Now we need a 0 here. So you can multiply row 3 by -2. There it is. Slide row 1 over it, and then just go column by column, combining. And this is what's going to replace row 3. This is going to be the new row 3. So we have our row 3 here. Now we need a 0 in this position. So multiply row 3 by -2. This is what you get. Slide row 2 over it, then go column by column, combining the terms. This is going to replace row 3. So this is right here. Notice we have our staircase form of zeros here, like a little triangle of zeros. At that point, you put the letters back on, the variables back on, and you do exactly what we did when we had the system instead of the augmented matrix. You back substitute, and you'll get the same answer, but this was quicker because you didn't have to write the letters over and over. The variables weren't written, and they were put back onto the end. The solution is the same.